everyone, and welcome to today's panel discussion on open science. My name is Cameron Riddell, and it is great to see so many of you here ready to engage in a conversation that's not just about research, but about the way that we do research, how we collaborate, how we share, and how we ensure that knowledge is accessible to everyone. I think we all would agree that open science isn't just a trend. It is a fundamental shift in the way that we think about discovery and progress. By making data, methods, and findings more transparent and available, we accelerate innovation, improve reproducibility, and foster a more inclusive and equitable research community. But of course, with change comes challenges: technical, institutional, and cultural. And that's why we're here today. Our panel brings together advocates from different fields who have firsthand experience navigating these challenges and finding solutions. Today, we'll discuss practical strategies for implementing open science practices, address various problems and barriers, and explore what the future holds for more open, collaborative research, while also highlighting the experiences of two of our open science ambassadors. So whether you're an early career researcher just starting to explore open science, a seasoned expert looking for new insights, or simply curious about how these principles are shaping the future of research, this discussion is for you. Speaking of our discussion, I want to invite you in our audience to engage with our panel. And the two ways that you can engage with our panel is, one, if you want to see a question discussed, please go ahead and enter that question in the Q&A widget in Zoom. Additionally, if you want to chat with your fellow attendees or even chat with our panelists, then please go ahead and use that Zoom chat. The Zoom chat does have an everyone feature where you can speak with everyone else who is here. And additionally, you have the host and panelist feature if you want to speak directly to myself, our panelists, and our other hosts. With that all being said, let's go ahead and introduce our two panelists who are going to be discussing open science with us. Today, we are joined by both Akshay and Dorra, and I'd like to invite both of them up on the camera so that they can introduce themselves and say just a couple of things about how they got started in open science and what their research background is. So I'll go ahead and I'll turn things over to Akshay first and then Dorra second. So Akshay, take the floor and let our audience know where you come from.
Hello. Good morning, everyone. So my name is Akshay. I started with this open science journey about last year, about a few months ago, possibly mid 2024, and it was surprisingly good. I learned a lot of things, and the whole point of getting into the open science was how I can use the learnings from this open science learnings and bring into my personal research and make it available for everyone so that I can build a good product and as part of my research. So that was the whole thing, summarize in short.
Perfect. And now you're advocating open science to not just use it in your field, but for others as well.
Yeah.
Excellent. Well, it's amazing to have you here, Akshay. I'm very happy that you've joined us today. We are also joined by Dorra. Now, Dorra, do you also want to take just a couple of moments here to introduce yourself, your background, and why open science is important to you?
Yes, absolutely. So first of all, good evening, everyone, and wherever you are coming from. I want to introduce myself. So Dorra, I am an industrial chemistry student at École Centrale Polytechnique Privée de Tunis at University Centrale Group, and DUTC Open Science Ambassador, proud of that. Also, I am a research fellow at the Advanced Space Life Research Institute and AWG member, Analysis Working Group. Also, I was a citizen scientist at the Universe. And lastly, passionate about open science, I was served as the brand ambassador and content creator. My journey for open science was a little bit can say new and old at the same time. I started 2 years ago when I attended the first NASA Talks Transfer to Open Science event, which was a workshop on how to build a better poster. And then I was following and exploring things related to open science. And after I participated in NASA Peer Group Challenge, which was about using public Earth observation data to create visualization. and using one of the three sustainable development goals that were mentioned at the challenge. And after it, I have attended the DUTC NASA Open Science training, and the real journey started from there because I had real access and knowledge to start my journey of open science. And from that time, I was an ambassador with the GTC for open science, and I got a physical certificate, a folder, and stickers with as I was one of the 2,000 learners of the program. With that, I can say it was one of the achievements that I had. So yeah, was the first journey.
Awesome. Well, Dorra, it is amazing to have you here join us for this panel. I know you bring a lot of insights, especially with your background. Now, we have a series of questions here to guide our panel discussion. And of course, if you're in the audience, you do have also the opportunity to enter your own questions if you want to have any discussion or see any discussion happen. But to help our audience follow along with some of the questions that I have, I'll share my screen. So behind me, you'll see my screen, and I'll hide in the corner over here. This will help us keep track of what question we're discussing. Our very first question that I want to hear a little bit more on is, what inspired you to become a DUTC Open Science Ambassador? Because of course, you don't need to be an ambassador to participate in open science. And I'm curious, how has that experience as an ambassador shaped your career or your studies? So Akshay, we'll have you go up first, and then Dorra will have you go second.
All right. So for me, to be honest, I was particularly drawn to the DUTC ambassador, open science ambassador role, because honestly, I wanted to bridge the gap between research and the real world accessibility. A big part of this initiative was to basically it was to shape my approach to science and data science, machine learning, and all those technical stack and the technical debt people usually have. And it's not just like a technical endeavor, but it was more of a collaborative, inclusive process for me. And it could be through workshops, the YouTube videos, or mentoring, advocacy. I've seen firsthand how open science empowers researchers worldwide. I'm sharing code with someone, across the continent, and they kind of reap the benefit out of it. So especially in the resource constrained environment, so YouTube, Discord, so all these things were kind of super nice, that they kind of facilitate the whole open source journey, and that was the whole reason. And UTC provided this platform, so I just wanted to do that on there. So that was my personal experience, how I got started. So
amazing. And actually, I think it rings true. And this is one of the reasons that I wanted to also do and help start this program, is because I see a lot of open science advocacy just speaking to the greater good, but there's not a large discussion over what are the actual technical skills that you need and how do you apply those skills. Because I know so many people who are just overwhelmed by open science and the background that you also need. And this is really similar to at least my first year in graduate school. We were all taking that intro to statistics class, and the professor says the first day, by the way, everyone's going to be using R. And the whole class was like, what is R? What's programming? Why do I even bother? And I think it's a very similar skill gap. And so I love the tangible aspect, the skills focus, because it's nice knowing that open science is a good option for us to have. But how do we bridge that gap exactly, as you said? So awesome. I'm so happy to have you as part of the ambassador program.
Yeah. And I just want to add one thing, and I totally agree with you on what you said, because that is something even I experienced, like coming to grad school. Oh, we're using R because that's like the industry standard. And why it should be an industry standard, because if I want to get something, if I want to learn something, it shouldn't have any technical constraints. And when I'm looking at those YouTube tutorials what DUTC is putting out, I get the gist of it, what I want to do, how I can solve this particular problem. So I kind of totally agree with you on that one.
Excellent. All right, let's pose the same question to Dorra to hear a little bit more about Dorra. What inspired you to become a DUTC Open Science Ambassador, and how has that experience shaped your career or studies?
All right, so my inspiration is also aligns with your inspiration too. And in addition to that, I will address this as a question. Actually, like when we think about knowledge, how like how does knowledge truly exist? If we as people didn't share it, didn't transfer it, didn't collaborate for it, or even we didn't make it at some point like transparent or reproducible. So like if our parents at some point hide their discoveries, didn't share their stats, or even they didn't left their biosignature, so to speak, we will stagnate at that point. So that's why I strongly believe in open science and its ability in shaping the humanities advancement. And I want to advocate for it loud and proud. So so this is really my vision or my inspiration to be a DUTC Open Science Ambassador. And to talk also, being an ambassador has really shaped my career and my studies in tremendous way because I think like being an ambassador is a responsibility and a commitment. And here we mainly talk about discipline. In addition to that, this experience has somehow ignited my creativity and my content creation skills. So, like particularly on LinkedIn, because through it I was sharing my journey to open science, and I've not only expanded my network but sharpened my ability to communicate like complex ideas clearly and engagingly. So, and even through LinkedIn, I got like an offer from the Advanced Space Life Research Institute to be research fellow. So, I have opportunities with being an ambassador.
That is amazing to hear. And I want to say to our audience out there, if you're not connected with Dorra on LinkedIn or following Dorra on LinkedIn, I would highly recommend it. She makes amazing content promoting the awareness of open science practices and why it is important. And Dorra, it's amazing to hear on the other end how other people have reached out to you and how you've grown your network by just meeting like-minded people who care about working with transparent methodologies. Awesome. All right, so let's jump into our very next question where we're going to focus on, well, open science can mean different things to different people. And I'm curious, how would you define open science and why is it important in your field? So we're looking for some discipline specific discussion here. So Akshay, again, we'll start with you and then we'll go to Dorra second.
Okay, so personally for me, open science, I mean, it's a lot of things, you know. But if I want to summarize and put it like in a very short way, I would say it's about removing barriers to knowledge. Okay, that's the biggest thing for me. It's about ensuring that the scientific output, it doesn't matter if it's data, if it's a software, publication, research, whatever we get out of a particular thing, like scientific thing, are accessible, reusable, and reproducible in all the scenarios. So that's very important for me personally. In my field, I'm a student now. I'm a grad student, but at the same time, you know, I do open source. I do a lot of collaborative coding. So this means for me that I have to leverage these open source tools and advocating for the FAIR principle, the FAIR data principles, and fostering global collaboration has been super important for me. And for me, the open science facilitates the whole thing, the approach that how I can. It's not just me, but I'm just a cog in a big process, in a big system. So for me, it's like I just that awareness, the self-awareness that okay, this is beyond what you can do, and the more people you have, like-minded people you have, you can take it to next level. So this is about just exploration and removing all sorts of barriers which are coming because of some knowledge or technical debt. So yeah.
Excellent. And Dorra, what about you? What does open science mean to you in your field?
So, open science, I can define it as collective effort by diverse individuals to advance global scientific impact. And I mean by that because when we have like open science is working, when we don't benefit ourselves only, we benefit the community also, and we advance global communities. So, and in my field specifically, having more open access journals, reproducible experiments, open results, open source software too, I think
Hmm.
at that point.
Excellent. So it sounds like a focus on the global collaboration that you get that brings open science. Whereas Akshay, correct me if I'm wrong, but it sounds like your focus for open science is kind of within study or across studies, reproduction or replication to make sure that our research is a little bit more sound.
Yeah, absolutely. Because for me, what I have experienced and what you said that is absolutely correct. So just to clarify, what I was trying to say is the major challenge is a cultural resistance. Sometimes if I see, oh, as you like, we start with the previous example. We are starting with a data science or machine learning problem, and we start with R. If there is a team of people who are specialized in Python, Julia, or different languages which are in the same domain, they might not have familiarity with R, and that should not stop them with the research. So for me, it's like it's important for me. It's not just using R or like all these tools, but like overall understanding of the concept. Like how can I make things more accessible? So if it's not R, okay, let's do it in Python or Julia, whatever you can understand, because the whole thing is we want to push the boundaries of research, what we are doing so far, beyond what we are doing right now. So, and there's systems like a programming language or like so the scientific tools that we are using, there shouldn't be any barrier. So that's the biggest thing for me.
Yeah, and I like the example that you brought in with the different programming languages, and I think one huge shift there is the use of these free and open source tools. Python, R, Julia, they're all free that anybody can use, anybody can download, and this is in stark contrast to something more proprietary like MATLAB. I can read MATLAB, I'm dangerous enough to read MATLAB, but as soon as the code goes a little bit above what I can just read at a glance, I'm going to want to execute that code. And Akshay, now that I'm not inside of a university setting, I don't have the money to pay for a MATLAB license because they are incredibly expensive. And we see this all the time, not just at programming languages, but also articles that you want to read. They'll be locked behind some paywall. And as soon as you're not at a large research institution, well, you're going to have to pay for that out of pocket. And I don't know a single person who's going to pay $20 for a single PDF. So I agree, it is all about transparency and it's all about accessibility, making sure that knowledge is available to all.
Correct.
Dorra, do you have any additional comments to make about the meaning of open science to you before we move on to our next question?
Totally fine.
All right, then let's jump into barriers and challenges. We've started talking about this, but I think there's a lot more discussion to be had. But what barriers or challenges have you observed in promoting open science practices, particularly in your respective regions or fields? And I would love it if our audience also got involved. If you don't have a question about this discussion, go ahead and share in the chat what barriers or challenges you observe in promoting open science practices. But Akshay, for our panel discussion, let's start with you, and then we'll switch over to Dorra next for barriers and challenges.
Okay, so I mean, I totally agree with Rob. In chat, like he was mentioning, like $20 for a single PDF. Like, yeah, that's crazy, and I don't think anyone's going to do that just for single PDF. Totally agree with you and Rob on this. So, as I said before, so major challenge when it comes to promoting open science, or like practicing open science in actual, academic or professional setting, is the resistance that kind of comes with it because when it comes to it's like oh, it's open science, you know open source, I'm doing it, I'm not getting paid, so when is the funding? Because this is super critical. Not many systems, many institutes, or like many universities are not ready to do this thing because of the funding issue. So that's one thing that, I would say, like, this is the primary barrier that I have observed when it comes to promoting open science. The other thing is, like, some researchers, they are like fixated that, oh, they kind of worry that open science might lead to losing the credibility for the work. So, and we can't say that it's a good or bad thing, and everyone has their opinion, so can't force anything on it. But it's like, all it comes down to money. It and credibility. So some researchers might have that skepticism that, oh, if I put things out there, I might not get the proper credit for what I'm expecting. Um, Funding is one other thing. The funding structure, they kind of prioritize proprietary output. So how you started OpenAI for that's one example, a massive example that we can see. Started as a good non-profit company, and now it's kind of getting to it, monetizing the whole thing. There's nothing wrong with that, but it kind of it's now pivoting or kind of deviating from its main goal. It's in the name itself, so it's now like kind of falling that thing off. And there's also like a digital divide, in my opinion. Not every region, or like not all. I mean, although we say it's like internet is like coming global, communities coming together, but not all the regions have equal access to the infrastructure that is required for open science. So that these are like few things in my opinion. Like since I've been doing this open science, passionately since a couple of months now, I've seen this thing. These are like big challenges or like barriers, when it actually came to educate and promote open science to a lot of audiences, like in the masses.
Yeah, it makes a lot of sense for the challenges. Now, I have my own thoughts on this, but Dorra, is there anything you want to respond to Akshay about, or your own thoughts on barriers or challenges that haven't yet been discussed?
Actually, I agree with Akshay for the idea that we have sometimes we have tools in open science that can make sure that, for example, our information is not stolen, like licenses. We have, for example, for ambiguity or for the researcher, we have RICD, which like an identifier for the researcher himself. So we have like, if we go with open science, there is tools that can protect the person that's implementing open science. For example, when you talk about having the risk of our work might be stolen by other individuals or entities, we can talk about Creative Commons license. And it does really protect us, because being open doesn't mean there is no restriction to. And that's what we learned during the training. Second thing, also the unfamiliarity with the concept. So sometimes it may take to accept it or even to adapt it. And at this point, we have to test the process. It takes time, but we can have like at the end a result for that. So
Absolutely, I agree with all of the points that you both made. I see the world's a little bit more divided in terms of these barriers. I see philosophical barriers and I see technical barriers. The philosophical barriers are going to be things where, well, we've been doing science the same way for hundreds of years. Why change anything? And we get a lot of that pushback, kind of the closed science perspective. And this leads into another barrier of, well, there's no incentive to do open science. We can speak to this greater good and that the world should be this way. And I can tell you that having more reproducible research is going to help us be more confident in the things that we understand or the things that we're trying to advocate for. But at the same time, by telling you to share your data, by telling you to share your code, I'm also asking you to do more work than you were 3 years ago or 20 years ago. And so right now, there's no real kind of financial incentive yet that's in place where research institutions will pay you more money or give you more grant funding if you promise to do things in an open and transparent way. There are likely a few that will give you more money, but it's not the commonplace, the mainstream. And that's what we're trying to shift here with our discussions as well as our awareness of open science that we're trying to spread. Now, the other thing I said were some technical barriers. And the technical barriers just arise from an unfamiliarity with the subject. And this was said in the chat, so I love that this came up, but also kind of training and skills. And we alluded to this earlier where, well, we simply don't understand the additional skills that we need in order to be more transparent. And additionally, from a technical perspective, if we're telling you to share your data online, well, data sets come in all shapes and sizes. And for most work, if you can post your data online, that is great. If you have, a 40 gigabyte data set or smaller, it shouldn't be too much of a pain to share that online. Now, if you do share it online, we do have to remember that anything you put online, well, it has to be stored somewhere. And if it's being stored somewhere, somebody has to pay for that service. And so although we want everything to be free to our users or free to our audience as much as possible, there's still some financial transactions that have to go around. And the issue that I see with this is if you want to publish, say, gold open access in a very prominent journal, something like Nature, and you don't have specific funding set aside for this, or your institution is not going to pay the APC or the article processing charge on your behalf. I was just reading on Nature's Gold Open Access to publish in their open access portion. It's $12,000. That is incredibly expensive. And we do have to acknowledge that, yes, Nature holding on to your PDF and any associated materials for you online forever should be an expensive service. But to ask an individual researcher to come up with that kind of money, if it's not already written into their grant, is going to be very hard to do. And so we have these two types of barriers, these philosophical these barriers where we just need to shift our thinking, but then we also have technical barriers, which are often overcome with some type of financial solution, but we don't want to place that burden on the audience, which is how we're doing things right now, where if you're a member of the general public and you don't work at a large institution, you do have to pay that $15 to read an article. And I don't know many many people who read scientific articles that they have to pay for that are outside of their own domain if they are studying something. So a great discussion of barriers and challenges. I love hearing how you both experience these challenges and you view which of these are prominent within your own fields. Akshay, any final comments here for our barriers or challenges?
Not a comment, but when I was listening to what you're saying, I kind of had this recollection of, oh, the same thing happens in my university too when we do the research. So I've been part of a couple of research groups in my university, and we're doing active research on different domains. I mean, I'm primarily involved in doing research in a couple of things, it's NLP related work. One of the project is about NLP. We're kind of building a RAG based models and stuff. And other one is about facilitating the lung cancer detection. So that we got the data sets and every single thing, but now the problem is the research that what we want to do is kind of, or the whole point of open science is why should I do the whole work again? If someone has done it already, I can use that thing and I can go beyond that particular point. I can just use that thing and start on top of it. But when we're trying to do this, a lot of articles, publications are behind paywalls and they're taking an enormous amount of money. So, and it's beyond the university grants and the budget. So sometimes we have to push the deadlines and we have to reinvent the wheel again, and it takes a lot of time and expertise, because all these other universities or all these institutes, they have been putting a lot of money into this thing for publishing all this research. But unfortunately, since it's behind a paywall and beyond the reach of the normal audience, we can't do a lot of things, and it kind of pushes the deadlines even further. So it is one of the barriers. So funding all comes down to money. So that is a big problem. That's something I totally agree with you.
Yeah. The money is a big aspect. And I agree with the individual in the chat who just posted that transparency matters too. Well, what's actually going on with the $12,900 that Nature would need to do something open access? And then how much does it actually cost? And what do the margins look like? It's still it's opaque from the publisher's perspective. And of course, that's going to be intentionally done so because they're seeking to make money off of this. But Dorra, any other final thoughts on barriers or challenges from you?
Yes, I agree with the idea that sometimes to ask ourselves this question: why should I do the work more than again, or do it more than I used to do it, just to be open science, to make it in open science? And at this point, we can say the person that will be implementing open science should be aware that benefiting the community will be beneficial to himself too. And it's not about being ourselves only. We are advancing a community and advancing a global and communities. And here we can discuss it at this perspective. Yes.
Mm-hmm. Excellent. All right, then on that note, let's jump into our very next question. And this asks, in your opinion, how can open science transform global collaboration and research and innovation? So we'll start with Akshay again and then go to Dorra. So Akshay, how can open science transform global collaboration and research?
Ooh, like this is
It's a big one.
so yeah, it's a big one. So for me, I have what I've seen. Okay,
Yeah.
this is my personal view on this thing. Is what open science does is it kind of levels the playing field across the board. So it allows researchers and like a single individual. I mean, let's say in an ideal situation, in an ideal world, we are experiencing and we're practicing open science. Okay, what it allows is it allows a single small indie researcher in a remote lab with limited funding, limited resources, also to contribute meaningful, proofs and findings and publications alongside researchers and scientists at major universities or institutes. So it kind of like evens out the playing field. So that is something I have seen, and like personally, I've seen in like the global science in the world. So it fosters these interdisciplinary innovations. Like for example, if I'm an astronomer, if I'm a machine learning engineer, like an AI engineer, and like GIS analyst or a climate scientist, we all can work. It doesn't matter if we are from one university or like different institutes. We can work together on a shared data set without the institutional barriers and work on getting this job done. We're solving the main problem. So that is something open science, like be very blunt about it. It evens out the playing field. It gives opportunity for all the developers, researchers, contributors to come on a stage and do what they're best at and get the job done. So that's something I feel, and I have seen that thing. So if you see DeepSeek, OpenAI kind of launched their like Chat GPT or like another GPT-4 models, and now it's like, oh, it's beyond a paywall. What people are doing, they're coming up with their own technologies. Like it doesn't matter how they do it. So that's like a different story for for rainy day. But it kind of brings a lot of people from different regions. Someone in a lab can build the same thing if they know that concept. And if we make it open, a lot of people can jump in and make it more accessible, make it more better. So, and again, and make it available for the masses. So it's a feedback loop, right? So, you test out, you give out the product, launch it, get feedback, improve upon it, and like rinse and repeat. So that's something I feel, open science can actually help in research and innovation.
Absolutely. And I love the point that you made earlier about it helps under-equipped laboratories or groups access those interesting questions that they want to ask but simply do not have the resources to collect data. And that's one of the things that I think NASA, as well as many other agencies, do very well with their data sharing policies, is that yes, satellites are incredibly expensive, and I don't expect a single lab at a single university to ever launch their own satellite. But thankfully, NASA makes a lot of their data available for free access. And that has that has created many different avenues of investigation that have all had very different questions asked of that same data set. So it really does empower our researchers. Dorra, what about you? In your opinion, how can open science transform global collaboration in research and in innovation?
So first of all, I would like to I agree on Akshay point, and I want to give an example for
Excellent. And Dorra, you just cut out at the very end for me there. So when you come back, I'd love to hear that example that you were alluding to, because I do find that open science isn't just about communicating with your colleague down the road. It really does open you up for a global scene or a global setting here. And so, Akshay, I'm curious, for any project that you've worked on, have you ever ended up collaborating with somebody you had no expectation or no reason to think that you would ever collaborate with them?
Oh yeah. So again, this is a personal story. So I've been maintaining Django since 2018. So it's not just me who's maintaining Django, and Django is a very massive project. Now,
Mhm.
if people don't know, it's like a web framework written in Python. So I've been one of the maintainers, and there's no money in it's open source project, right? So anyone can come in, can join in, and now I'm being maintaining that thing. It's like, oh, like we met, there was like one instance where like I met a fellow maintainer at a conference, and I've been talking to him on GitHub, and that's the only like interaction I have. So I know this person with his username, but I have no idea who this person is. And when I met him in person, it was really good experience. Like, we are like two people across the continent, different timelines, different time zones, and not timelines, but different time zones, and we're talking, we're solving one problem. And when we met, it was a really bizarre and like fascinating experience for me, that how these two individuals who never know their real names actually coming on a platform working to solve one problem which they're not getting paid for. So
Yeah.
that was like, in my opinion, that's a personal thing that I have seen and I've experienced, that it feels really nice to meet the fellow contributors. And this was like on a global scale, because I was in the UK and this person was, I guess, in India. So when we met at a conference, I was like, hey, how's things there? Like, how do you contribute, and how the culture there? It's you get to learn a lot of things. So that's something I would say. It's in my opinion, open science does much better. It brings people together of
Yeah.
different cultures and all those things.
Yeah. I've also found that when you kind of put yourself out there, because that is one of the scary parts of open science, is you're putting your work out there in a very transparent way. Whereas with the typical paradigm, the closed science, you put your very good looking PDF up at the end, and then maybe reviewer number two tears it apart when you submit that manuscript. But with the more open reviews, the thing that I have seen is typically people are nicer and they are more constructive because their comments are also open to the public. And so, although it's scary to put yourself out there, I have seen many instances where putting your work out there for effectively criticism ends up being a more constructive and easier process than doing the closed door review. That said, with the closed door review, you do get, I'll use the term guarantees very loosely here, that you're getting some subject matter experts, people whom you would consider colleagues in your particular fields, where within open formats, that's not necessarily the truth. However, the one thing I do love about operating in the open is something you alluded to, and that is the fast feedback mechanism that you can get. And you get very detailed feedback there. One of the examples that I love to talk about to advocate for open science is, first, if you do things in a closed manner, aka you maybe publish your manuscript, you don't share your data and code, is that if there's any mistake there that's not evident in the text of the manuscript, it's going to go unnoticed. And I know many people who really take advantage of this and say, as long as I get that nice looking PDF out, I can sweep all the other things under the rug and my life will be okay. But this leads this leads to problems in science down the line. Say 2 years later, somebody else is citing your work that you maybe made an error in the analysis, but you made it look good in the PDF, and they simply don't know, and they can't replicate your work. So they're sitting there scratching their heads, wondering, I really thought my hypothesis would be accurate based on this previous literature, but the previous literature is faulty. And then if they're if they're very into it, they'll dive really deep and question your basis for the research and then come out with some other study that disproves your work. And then you have that common conflict that we've seen go back and forth where one author publishes one thing, somebody else publishes another thing. That's how science moves forward. But what if we could do away with that whole back and forth process for a subset of these problems, and we could just share our code, share our data, and if I get some results that are different than yours, I can go look at your code or your data set and say, oh, I noticed in your code there was a small typo in your analysis, so the numbers that you got as an output aren't actually accurate because you need to change this parameter ever so slightly. And that's, instead of happening on the scale of years, we can shrink that down to a matter of months. And that's why I love this kind of sharing. And that's why I think open science really does transform global collaboration, because you'll get people reviewing your work as in full fashion whom probably would have never otherwise considered looking in depth at your work simply because you made it accessible.
That is so true. And coming back to, I mean, you know this much better, but like in the trainings, you have always given this example about the climate data. So I'm not sure about like, the time, the years in that case, but like in the early 1990s or something, we had one particular research about the global temperatures, and it was a fault. I would not say a faulty research, but like they did with what they had, the technology at the time, and couple of years later, almost a decade later, if I'm not wrong,
Yeah.
they came up with another study which kind of falsified that thing. So I was like, oh, it's not what you claimed was wrong. That happened only because that thing was made out public, that made a lot of difference. So that global collaboration, I'm not sure if these were the same entities or something, but at the end, you put things out there, you get feedback, improve upon it. So I totally agree with you. And
Yeah.
this one is like a very good example that a lot of people who have already attended the trainings, they might know about this thing.
Yeah,
So
yeah. And also, honestly, it does help with that. I don't have a million emails to respond to, because then if somebody says, "Hey, I read your study. Can I have that? Can I have the data?" I'll be thinking, "Oh man, where did I leave that data set? It's on a different computer, like it's still in the lab." Versus nowadays, you say, "Well, I shared it alongside the manuscripts. You can go to Zenodo, Harvard Dataverse, etc., to find it. Here's a link to this specific version of the data set." So I love seeing that effort of collaboration there. But let's jump into our very next discussion question. And I'm curious for you, Akshay, how did the DUTC NASA Open Science Skills Training prepare you for maybe something you're working on currently or in the future or even in the past?
so there are a few things. Okay, in here, the first thing that actually comes to my mind was like, like, okay, the trainings, the DUTC trainings, they kind of provide very hands-on experiences, hands-on things with the tools that are critical for open science. It doesn't matter, like, it's not just for open science, but like, for my personal research, for my personal, like, learning, my personal growth, or the YouTube videos, or like the blog posts, or like all the small snippets of things which are, or like the workshop that they have been doing. So they have been certainly helpful for me personally, and as simple as setting up a Jupyter notebook or understanding Jupyter notebook. Everyone uses a Jupyter notebook in machine learning domain, but like how many people actually know that? That is very important. So from learning or understanding Jupyter Notebook, as basic as Jupyter Notebook, to cloud-based data repositories, Zenodo, using GitHub or Git clients properly. That's one good thing that like these trainings have been providing me personally, and I kind of value that thing, and it kind of prepares me for becoming a better contributor in the whole open science space. And importantly, it kind of instills the mindset of openness, how to structure code, how to maintain a large repositories, or like, how to explain things in a way that people understand. How can I make things reproducible and engage with the global researching communities? So as we started off, there's technical debt among a lot of different cultures. But what I have seen, the training has kind of reinforced me personally the importance of structured openness. I would call it structured openness.
Mhm.
It's not just making the research public, but it's ensuring that it is well documented and reusable. So, because that is one important thing. If I cannot read your code, if I can understand your code, how in the world I'm going to use it? So, I want to do that. It kind of influenced how I design my open source projects, and I do a lot of open source work. And looking back,
Yeah.
I'll give you one personal story. Last night, I was looking back at my Git commits, and I was like, oh, how they have changed over the years, and now they're getting more better and better and better. And I know it will get better in future, but like how the trainings, or like what I've been doing the open science work, because now there are more eyes on me, or more eyes on my work. So I have to be cautious how I think, how I put things out there. I have to put out code which is maintainable and reusable for the other people. So this training have facilitated me with all those technical stack. So yeah.
Awesome. And actually, you reminded me of a course that I helped design and deliver at Johns Hopkins University. We taught undergraduates how to write, write a modern research paper. And so, of course, part of this was using tools and things like Jupyter Notebooks and Git for version control, as well as even integrating some LLM type of things. And we had the students write a rough draft of a paper of a topic on their choosing. And then we asked them to use an LLM to refine their paper. And we told them not to let the LLM rewrite their paper because that's horrible. But instead, we asked them, the LLM, to provide feedback for them as well as reasonings for that feedback. And then it's up to the student to incorporate that if they saw fit. But the really neat thing was that for every revision that they would do themselves with the LLM, that would be a new commit in the Git history. And inside that Git commit, we told them to make very good use of those commit messages and maybe even paste some of the LLM response as well as the question that you asked for it. And then filter that down to a couple of bullet points as to the changes that you made and why. And I find that these Git commit messages, whether you're working on an open source project or you're reviewing somebody else's work and how their project changed over time, having that metadata as to, I made a change here, this is why I made this change, is incredibly important, not just for other people coming to read your code, but also for you 3 months down the line when you're thinking, why did I change X from 4 to 5 3 months ago? What was I thinking then? And so I do find that some of these things like version control, and not just using I hate it. I dislike it when people rely on just timestamped version control. You know, your Dropbox syncs up a new version every day or every 1 hour or something of that nature, because you're never going to say, okay, well, what did this look like on June 1st, 2003? If that is an interesting question to you, you have the ability to go back. But I'm more interested in saying, well, when reviewer number 2 tore my paper apart, what changes did I make right after that? And with the previous approach, you'd have to go back to your email and see when you received something from the reviewers, and then you would have to then find that timestamp with the version control.
Yeah, I totally agree with you. And that was the same process for me yesterday because I just wanted to, because I was looking, I'm kind of replicating another project again. And I was like, oh, what did I do here? And why I changed that thing? So I was like, oh, let me just see in the comments. So I went to the Git commits and I was looking at the thing, and thankfully, like all these trainings are coming handy now, that the helpful messages, the timestamps, and oh, why I'm doing this, these bullet points, like they are coming handy now. So what I did like a couple of months ago as part of, oh, let's just explore this technique to streamline my work, is kind of paying off now a couple of months later. So that's one personal benefit of open science, in my opinion, for me at least.
Awesome. Well, actually, on a related note, besides the use of Git or version control, are there any other specific skills or tools from the training that you've applied to your research or some other work that you're doing?
Oh yeah, definitely. So there's okay. One is one thing that I've done is started heavily using Vim, because that's something like I've seen in the trainings. Oh, everyone's using Vim, so I was like, oh, let me just try using Vim. So that's one personal thing as like an achievement. Oh, this year I want to get good at Vim. So that's one. But other things are like how I can use uh the way like the trainings have been laid out, and there's a snippet of code. We define some data structure, like something like a setup code, and how it works, how do we transform it. It doesn't matter if it's a simple polars, like work, or like if I'm working with pandas or something. This one good thing of using this library is these packages are like this million different ways of doing it. But what is one way that is acceptable by everyone, that is known by everyone, or that is which is basically esoteric, let's say. So that is known by the people in the community. So these trainings have certainly helped me making my code more maintainable. I would not say if there is any tool that because I've been using all these tools like Jupyter, Git, and all those things. But the skill that I've developed is I don't want to use fancy shortcuts to make my code look pretty, but I want to use things which are understandable by the general broader community. Because down the line, 6 months later, if I come back to this code, even I should understand what I've done, not confuse myself with, oh, this looks good, but what it produces at the end, I have no idea. And I don't want to do that. I want to see the code and, oh, this is what I get out of it. This is how I did it. If I want to share the code with someone, if I'm giving my code snippet out, like, maybe I'm showing the same thing as an assignment snippet to my colleague from school, is like, hey, do this step, you'll get an output. Why should I use log, ilog? These are like the technical details. I'm not going to go into it, but when you're supposed to use what, that technical understanding, what is better, so in Python we have more explicit is more explicit. That's good, right? So one of the things in Python is like you have to be more explicit. So that is like, the explicit behavior that kind of has been instilled too much in me, and I've been using it a lot, and it has helped me and my students to write code in that way. So that, write code, good code, maintainable code, and something that other people can understand, not just you. So that is one skill that I've learned from this kind of training.
Excellent. I'm very happy to hear that. And I think even if you're not, for our audience out there, if you're not writing very in-depth code and you're concerned about the readability, of course, there are different techniques or approaches you can use. A lot of people like to add comments into their code, but I also find directly from the Open Science Skills training, writing a good README is invaluable. Again, not just for other people, but also for yourself. And Akshay, I don't think you would be surprised at how many GitHub repositories that people have asked me to look at. And I click on the link and there's like 2 or 3 files in there, no description as to what they are. And they're pretty long, very mechanical looking code. And after they emailed me this link, I emailed them right back. I say, what does this do again? Just so I know, just so I have some context for what I'm looking at. And so I think the README and some of the other pieces of metadata are very important here.
That is so true, because now coming back, when I was working on one of my projects, I was asking you guys to review it, and like at that point there was no README, so I don't expect you guys to give me like any proper suggestion. I mean, you did help me out, but now that I put README, it is accessible. It's not just for like 1 or 2 people that I ask, but to the general masses that are kind of interested in helping me out, irrespective if I'm asking them or not. So that is something. The READMEs or all those things play super, super critical role. So writing maintainable code is important. That is good, but writing code that is something you can understand 10 months down the line is more critical. So I totally agree with you. READMEs are critical now. So yeah.
That, and I really appreciate that, not just for my own repositories, but other repositories that I look at, they've started including that citation file, the citation.cff, and it just makes citing these things that I use all the time so much easier, because I know many people who do not cite NumPy or some Python package that they're using, and they just say, oh, we analyze these data using this. And I sit there thinking nowadays, there is a publication about this that you should cite because you used a tool to produce some scientific output. But I'll digress from that rant before too long. Okay, and Dorra, same question to you. Are there any specific skills or tools from the Open Science Skills training that you've applied in your research or other work?
Absolutely. So yeah.
Yes. Perfect. Okay. Well, looking at the time, I think we have just enough time for one final question for us. And the question that I would like to ask, we'll start with Akshay first. Akshay, if you could give just a single piece of advice to attendees on how they can start incorporating open science practices into their work, what would it be?
Oh, so one piece of advice would be like, again, it's coming personally from me, is that's something I experienced and I implemented, was start small, but be intentional about the whole thing. There's nothing wrong. Some people are like, oh, we want to write the whole thing and then publish out. No, it's okay. Like, do the agile methodology. Start small, put out things, take feedback, make your code public, document your data sets, and everything. As you said, like oh, we are using NumPy, Matplotlib to do that. There has been research papers who have resulted into these tools. Cite those things, add those things, engage with open source communities, and because every step that you take in this journey, knowingly or unknowingly, you're kind of being an open science practitioner. So, and it's like, it's a journey. So you can't just go there instantly. You have to take steps. So start taking small steps. Don't jump. You don't have to run. Start baby steps. Put out your code and make it accessible. And whatever, if you make it accessible, try to write it in a way that makes you see like, oh, what if I want to use someone's code? How would I expect it to be? So think from that perspective. So start small. There's nothing wrong with that. Be intentional that whatever you're doing, it's for larger good, and don't expect a lot of good responses, because there would be some criticisms, because since it's the first time, so there would be some harsh criticism. Oh, this is not right, this is not good. It's okay. Take it, work on it, implement it, get better, and keep this feedback loop going on and on and on. So that is something I would say. There's nothing wrong. Start at some point, but what we discuss, right? Think from a larger, broader perspective, that how your code is going to be impactful. It might not be impactful for anyone, but it might be impactful for you 10 months, 6 months down the line.
Yeah.
So don't have any hardcore expectations, but start somewhere, and early you start, that's much better. So
absolutely, I very much agree with the start small, because there's so many things that we talk about that are different components or different levels of necessary to be quote open. But I do understand that there's a lot of technical skills, and it's going to be a lot of things that are new to most people. And so the small things that you can absolutely start with is, the next time you collect a data set and you publish on it, make sure that you share that data set. Whether you need to use a third-party tool like Zenodo, or the journal that you're publishing with asks you or has an option for you to also upload code and data alongside that, go ahead and do it. It's only going to help build confidence in the results. And I don't think you need any technical skills or advanced training to simply drag and drop your data sets, whatever that might be, onto the internet effectively. Now, for those who are thinking a little bit more technically oriented already, and maybe they do have some good mastery or understanding of a particular programming language, there are different communities out there for you. So if you're looking, and in the future, I want this to be even more important than it is nowadays, but those like JOSS publications, Journal of Open Source Software, I know many PIs or hiring committees even who they don't really count those as real publications, which I think it's a sham. But there are communities out there. If you're thinking, hey, I want to write a Python package, or I want to write an R package, you have the R OpenSci and the Pi OpenSci communities who are academic researchers, just like many of us. And they are there to help you along the way, to help you fill in those gaps of, I'm not an expert at Python or at R, but this is something that I want to do. And so there are resources out there, and that's part of our global collaboration and where we want science to go in a more constructive and collaborative future. But Akshay, any final thoughts or comments before we wrap up for today?
I mean, I don't think I have anything, but like, again, one personal anecdote was, you know, this one thing. So as you said, like, start small. So these open science communities, they actually play a super, super important role, because, these people are like, passionate about like, about the work, about reproducing the work, and like putting it out there and getting feedback. So they always expect new contributors. They always welcome them. So that is something I've seen. So the communities are super, super welcoming. You go anywhere, they're super welcoming.
Mm-hmm.
And one thing was, I did one patch for QMC, so PyQMC, and I had a good experience. I have no idea what I did in that patch, but like, it was accepted, it was added, it is one of the features. So now I've been a contributor also. I'm not a maintainer by any means, but like, and I'm a contributor now for this larger good. Why? Because I started small, I'm not ashamed of, oh, will I be accepted or not? Will my work be accepted or not? They just took it, whatever feedback I've got, I worked on it, I revised the patch and sent it back. So people are super welcoming. All you have to do is put yourself out there. So, yeah.
Absolutely. Jump over that barrier, that scariness of putting yourself out there, and just go try it. And
Yeah.
chances are you'll get a good response, though it's not guaranteed. You might experience some setbacks or some criticisms that you're not open to hearing, but that is the price that we pay to be more open and more collaborative in nature. And of course, the longer that we advocate for these things, the better your experience will become. With all that being said, as we wrap up today's discussion, I hope it's clear to everyone that open science isn't just some ideal. It is a practical and necessary shift towards a more transparent, collaborative, and impactful research. The challenges are real, but so are the opportunities that we have here to make open science, or to make science in general, more reproducible, equitable, and innovative. Whether you are taking the first steps towards open science or you are already deeply engaged, every single effort counts in building a more open research culture. And I want to thank both of our panelists today, Akshay and Dorra, for sharing their insights, and to all of you in our audience for being a part of this important conversation. Let's keep it going, and I hope to hear from many of you in the future. If you haven't already, please do reach out to all of our panelists, Akshay and Dorra, as well as myself on LinkedIn. Feel free to connect and stay in touch. But I hope to see you all again at a future seminar or at a future panel discussion sometime real soon. Thanks everyone for joining, and I'll see you around.